For 100,000 years, humans have looked up at the night sky and wondered about those awesome points of light. What are they? What are they made of? How did they get there? They didn't have the technology to find out, so they guessed that magical beings had created it all. If you prefer making wild guesses instead of using observation, measurement and calculation, then here's a sealed box. Spend the next 10 minutes guessing what's inside and come back again at the end of this video. Because this video doesn't cover what we guess about the universe, but what we know, and more importantly, how we know it. How do we know where the stars and galaxies came from, and how old they are? The first person to take a stab at gauging the scale of the world around him was the Greek scientist Eratosthenes of Cyrene. He knew that on the longest day of the year the sun was directly overhead at Syene in the south of Egypt, but cast a shadow in Alexandria to the north. By measuring the length of the shadow, he could work out the Earth's diameter. But while the Earth might be spherical, the dogma of a fixed Earth still held sway, backed by a powerful church. Problem was, this didn't fit the observable evidence, especially the observation that some wandering stars, or planets in Greek, had very erratic orbits around the Earth. When the telescope was invented, these planets turned out to be very different to the fixed stars. But it wasn't until Johannes Kepler calculated the exact orbits of the planets that a model of the solar system at last fit the observations. His law of planetary motion turned this into this. In the 18th century, a transit of Venus across the Sun, timed at opposite ends of the Earth, made it possible to calculate the exact distance of the Sun, and by extension the distances of all the known planets. But that still left the stars. The easiest way to measure their distance is a system called triangulation, which is used to measure distant objects on Earth. With stars, the baseline is the Earth's orbit around the Sun. Take an angle measurement here, and 6 months later here, and just do the math. This principle was known in the 17th century, that their instruments simply weren't accurate enough to measure such a tiny angle. But in 1838 the technology had caught up. The Prussian astronomer Bessel found that the binary star 61 Cygni was an astounding 60 trillion miles away. It was a distance so huge that it had to be measured in terms of the number of years it took light to cross it, 10.3 light years. Our universe just got bigger. Triangulation only works for stars up to 100 light-years away, but it was a start. Knowing the distances of these stars, astronomers could work out the relationship between a star's distance and its brightness, because closer stars are generally brighter than distant ones. Using this calculation, they could now estimate the distance of the faintest stars they could see. It was only an estimate, but our universe got bigger again. We seemed to be on the edge of a huge wheel of stars in space. While the brightness of a star gives us an estimate of its distance, confirmation comes in another trick of triangulation. In 1987, a star was seen to explode inside our galaxy. The exploding star is called a supernova, and it's very bright. As it happened, this particular supernova was surrounded by a huge gas cloud far out into space. The light from the exploding supernova raced across the gap, and 8 months later it hit the surrounding gas cloud. Cosmologists saw the reflected glow. We know the speed of light, so we know how far it can travel in 8 months. And that means we know the distance between the supernova and the gas cloud. All cosmologists had to do is measure the angle between the two as seen from Earth, and once again it's simple triangulation. We can work out the distance of the supernova, 169,000 light-years. That means we're looking at an event that happened 169,000 years ago. Our universe was now huge. By simply observing and measuring, we'd calculated a scale in time and space that was far greater than Bronze Age people ever imagined. But one question still confounded scientists. What are all these stars made of? To understand the evidence, we have to understand